All right, so 2.1, linear equations, functions, and models, page 180. Skipping ahead from just regular old linear equations into some story problems. Example 4. Together, a dog owner and a cat owner spend $376 per year on vets. Okay? A dog owner spends $150 a year more than a cat owner. Why? The dog's bigger?
People like their dogs more.
Yeah, people like their dogs more. Cats are stupid, so who wants to spend money on them?
Like yesterday. It's making me sad.
My niece has a cat. She had a picture of it on Facebook, and it was the fattest cat I've ever seen. I mean, it's huge. It was sitting up on his haunches, and it was like the footprint of the cat butt was like this big. And she says, "My cat's not fat. He's just easy to see." It's like, oh my word. I hate cats. Anyway, did I ever tell you my cat story?
No.
Okay, so all my dog and cat stories are over. So that ends up being how much you spend on your cat and your dog. All right, so let's keep moving along here. A couple different formulas because you're going to be doing a few story problems here. And one of the, well, let's skip some of these story problems and come back to them if we have time. A couple of the formulas that you're going to be using, which you've used for quite a long time, is D equals R times T. Distance equals rate times time. You're also going to be using this one. Interest equals principal times rate times time.
Business math.
Yeah. Principal is the cash that you have in hand that you're investing. Rate is the percentage of interest that you are either paying or you're earning. Time, obviously, is how much time passes, depending on whether or not they want it in years or months or whatever, or days. So, mostly in years. Which bring, like I say, we have time, we'll come back to some of those, but I do want to jump to 184 and do zeros of linear functions. That this really won't take too much time. And zeros of linear functions sounds really hard. It's not. I've already kind of prepped you for that. An input for which a function output is 0 is called a zero of a function. So, for instance, if I give you a function and I tell you it's 2x minus 4, okay, whatever makes this, why would you say that there's only one answer that you can possibly have with a linear equation? What's the exponent up there? You can have one answer. Plus, if you have a linear equation, are all linear equations functions? Yes. Which means they only cross the x-axis one time because they're a line. They're not a curvy line that comes back up and crosses it again. It crosses it one time, so you only have one option for a linear equation. You only have one zero of a function. Okay. Okay, as far as formulas are concerned, one of the things that they're going to do is they're going to do some abstract algebra for you, or giving you some more abstract algebra. And I think it's good for you to practice things like this, where they give you something like this. What is that a formula of?
Perimeter?
Perimeter of what?
A rectangle?
Perimeter of a rectangle. Good. So, perimeter of a rectangle is 2 times the length plus 2 times the width. If the book says solve for L, what they want you to do is algebraically make this, rather than P equals 2L plus 2W, they want you to rewrite this in terms of L. Okay? So in order to do that, they're going to take away the 2W from both sides, divide by 2, and you're done. Okay? So they'll ask you to do something like that. Solve for L, given this formula. Okay? All right, that takes me back to our motion formulas that I had written up here before. D equals RT. All right, so we've got 2 airplanes. One airplane flies at a cruising speed of 500 miles an hour. I'm going to make a little box. I do so much better with these story problems when I have cool boxes to okay, so I have one airplane. Let's call it a 737. And then let's call our other plane a Dash 8. Okay, so we're looking at 2 airplanes there. One has a speed of, that's our rate, of 500. And our Dash 8 has a speed of 302. Okay? What they're telling me here is we're going to let t equal time, and d obviously going to be equal to distance. All right. Suppose that our Dash 8 takes off and travels at its cruising speed. Okay, so our plane, our Dash 8, takes off and is traveling here at its cruising speed. So this is our Dash 8. So there's our airplane. An hour later, our 737 takes off and follows the same route. So an hour later, our 737 takes off from the same place. I want to know at how far away from where they took off that both of these airplanes will be at the same place. Okay? So our 737 has to fly faster in order to catch up, because he's already an hour behind. So let's look at what happens to our time. What do we know the least about as far as the time is concerned? The 737 or the Dash 8? We know the least about the 737 because we at least know that the Dash 8 took off an hour before. So the Dash 8 is already an hour ahead of the 737. We know nothing about its time, but we do know that the Dash 8 is an hour ahead of it. All right, this is the hard part. Well, not really the hard part, but the part that gets to be a little bit confusing. Because we're not interested in 2 separate distances here between the 737 and the Dash 8. What we're interested in is at what point have they flown the same distance. Even though one is flying faster and one is an hour ahead, eventually we've got these 2 planes that are flying like this that both take off from the same airport. This one's flying along, this one flies, and it catches up. And at some point, they will be exactly the same distance from the airport. Yeah. Okay? So what that's telling me is at some point in time, which is the answer we're looking at, our distances are going to be the same. At that point in time, when the one overtakes the other, they will have traveled the same distance. That being the case, if distances are equal, it's real easy to put this together. So let's look at the 737. If we look at D equals RT, we're actually saying that the distance equals rate times time. And in the second one, d equals RT, we're saying that distance times time. Okay? So, if our distances are the same, what do we know about those expressions I just circled? Those are going to be the same. So, what I have here is 500t equals 302 times t plus 1. Those are equal to each other. You find t, and you end up with t equals 1.53-ish. I mean, you're just at an estimate there. Is that what they were looking for in this problem? How long will it take to overtake? Yes. So that is the answer that they gave you. If they wanted to find out how far apart they were from the airport, you'd have to take that time and plug it in times the rate in order to find out how far away they were from the airport. So, but anyway, that's that one.